Hi everyone. We will be learning to make graphs faster for solving many different questions in maths. This is an extremely important concept from the point of view of JEE mains, JEE advanced, and anyone taking any other competitive or other entrance examinations. You will be learning how to create graphs of very complicated equations very fast and learn an alternate method to solve equations nicely and accurately. So let's jump in. Hi friends, let's see what we will be learning today. So first part of learning how to make graphs is to understand different functions, and we will start with polynomial functions. What are these polynomial functions? These are basically some kinds of equations which will have terms like y, x, z, etc. And we will start with the linear equations, which is y equal to x. Now starting with the graph fundamentals, you will first draw the x-axis and the y-axis. You can do it in rough, you don't need any graphs for this. And by looking at the points of x and y for this equation y equal to x, you will notice that every point corresponds to itself. So for example, 0, 0 is a point on the straight line, 1, 1, 2, 2 is a point on the straight line, and so on. So if you just plot it, it is a straight line at 45 degrees to the x-axis and 45 degrees to the y-axis. Now coming to the next set of equations, we will be focusing on what we call the quadratic equation. The specialty of quadratic equations is that here the degree of x will be 2, and we will start with the most basic one, which is y equal to x squared. Let's see what it looks like on the graph. So this, if we plot it on the x and y, for a value of x is 1, y is 1. For value of x is 2, y is 4. For value of x is 3, y is 9, and so on. So if you just plot them, you'll see the plot kind of goes up faster than a linear equation. And since the negatives are also very similar, so when x is minus 1, y is 1. When x is minus 2, y is 4. When x is minus 3, y is 9. It kind of looks very similar on the negative axis side also. And coming to the last part, which is cubic equations. This will comprise of equations where the power of x is 3. And here, again, if you plot the graph of y equal to x cubed, you will find somewhat similar graph that we had for y equal to x squared. The only thing is it will rise up faster than y equal to x squared. And on the negative x side, it will go down because now it's a cube. So a cube of a negative number is always negative. Some important things to note about these three graphs, and we'll have to remember these, how they look like. For y equal to x, it is always and always a straight line. It's a very, very important point. Any equation of the form y equal to ax plus by plus c is always a straight line. For any equation which is of the form y equal to x squared, it will be a parabola. Or very important again. Always need to remember this. The next piece here is to note certain things. So what do we need to know here? For the linear equations, that is y equal to x, we'll have x can take any real value. So x belongs to all real numbers. Y also belongs to any real value, which is y belongs to all set of real numbers. For the quadratic equation, however, x belongs to all the real numbers. It can take any real value for this equation. However, for y, it takes only the positive real values and 0. For the cubic equation, again, x can take any and every real value, and y can also take any and every real value. So this concludes the basic equations for polynomials. Next, we will learn about transformations. This is the most important part. While the ways to solve questions are varied when it comes for solving equations, graphical transformations actually empowers you to create all different sorts of graphs very easily. Now there are many different forms of graphical transformation. We will learn the fundamentals first. So the first fundamental is when we have to translate from a variable x to a variable x plus minus some constant a. So what that generally means is the translation will happen only across the x-axis. So you will translate it, the graph, whatever you are making, right or left on the x-axis. So let's take an example. We know what the graph of y equal to x looks like. We will try to make the graph of y equal to x minus 5 from there. So how does it work? We've already learned what y equal to x looks like. It's a straight line at a 45-degree angle with the x and y axis and passing through the origin. Now, for y is equal to x minus 5, the whole entity of x minus 5 can be considered as capital X. So if you see, this is again of the form y equal to x. However, in this, where does capital X shifts its origin to? So capital X here is x minus 5. That means the origin is getting translated from 0, 0 for the small x to 5, 0 for the capital X. How does this work? Just see wherever, look at x minus 5 is equal to 0. So x will be equal to 5. This is called translation or shift of origin. So if I plot y is equal to x minus 5, first I will plot the y equal to x. This is an imaginary line you can think of when you are trying to create it. But your origin now will be shifting from 0, 0 to 5, 0. So y will now be x minus 5. It will be again a straight line at a 45-degree angle to both the x and y axis. The only difference being now, instead of passing through the origin, it will pass through 5, 0. We can do another example to see exactly how the translation works for other forms of equations. So you remember we did y is equal to x squared, which was a parabola, and this also was passing through the origin 0, 0. Now let us say you have to create the graph of y is equal to x minus 5 whole square. Now see here, these two equations, if you see, they're kind of very similar, right? Instead of x, it's just x minus 5 now. So how does that work for us? So for the parabola, it was centered at origin. Now my origin needs to shift in order to create the new parabola. So where will that origin shift? Let's say it shifts to a point A. And as we know from before, this will shift to 5, 0. So at 5, 0, we create a dotted y-axis. And we just create the parabola around that. That's all. So the parabola, the shape remains intact. Everything else remains same. Only origin shifts and your parabola shifts, maintaining its shape. So the fundamental theory here is keeping everything else same, only graph will translate across the x-axis whenever there is a transformation required from x to x plus minus a units. Now this will be an exercise for you guys. First, you should try it out on your own and then look at the solution of how to create it. So let's say we want to create the graph of y is equal to x plus 3 whole square. How will this work? So going into the solution here, we create firstly the x and y axis, and we know from before what the parabola y equal to x squared looks like, which is a very simple centered at origin, a bowl-shaped figure, almost a bowl-shaped figure. And if we have to consider x plus 3 as capital X, then where will my origin shift to? My origin now shifts to minus 3 comma 0, because clearly x plus 3 is equal to 0 when x is minus 3. So instead of going towards the right this time, my origin will move towards the left, and this point to which it will move is minus 3 comma 0. So at minus 3 comma 0, I'll construct an imaginary y-axis and create the parabola which is being shown here. So this concludes the lesson on translation across x-axis. Now let's look at the second kind of transformation. This is translation for the y variable. So translation from y to anything which represents or looks like y plus minus a. Let's look at this through an example. The principle here will remain the same. So what you were doing before, you will be doing the same exact thing here. The only difference being, instead of translating on the or along the x-axis, now you will be translating along the y-axis after you have identified where the new origin should shift. And as you can imagine, the new origin will be located somewhere on the y-axis. Let's look at the example now. So we already looked at what our y equal to x is. So let's try to plot some different kinds of equations, like y minus 2 is equal to x. Now for y minus 2 equal to x, what do we need to focus on? We have to start with y equal to x. So let's plot that quickly, and let's look at the equation y minus 2 equal to x. Instead of y minus 2, you can think of it as capital Y equal to x. Now capital Y will become 0 wherever y minus 2 becomes 0. So where does my origin shift to now? The origin will be moving upwards. So it will be moving from 0 comma 0 to 0 comma 2. Let's look at this movement, and let me quickly get there. So as you can see, since this moves upwards to 0 comma 2, my line will still remain the same. When I say remain the same, that means it will still have a 45-degree angle with the x-axis and with the y-axis. The only change being the line now moves upwards along the y-axis, and now it passes through 0 comma 2 instead of 0 comma 0. Let us look at one more example like this, but for a quadratic equation. let's try to plot the equation y is equal to x squared minus 5. Now you'll see a notable difference here with respect to the previous example that we did. Previous example was x minus 5 the whole square, whereas this is not x minus 5 the whole square, it's x squared minus 5. So we cannot treat this like we were treating it before. So we will reorganize this equation a bit and we will write it as y plus 5 is equal to x squared. Now if we again look at this equation y plus 5 equal to x squared, we will have to think in terms of bringing it into the form of y is equal to x squared, which is, and for that we will start with our original parabola, which is y is equal to x squared. Once we have drawn this, we will try to locate where my origin now will shift. So y plus 5 will be y, capital Y is equal to x squared now. Capital Y becomes 0, 0 when small y goes to 0, minus 5. That's easy to see. So clearly the origin point has to move downwards to 0, minus 5. Once it has moved downwards, then it is easy to plot the parabola. So you'll have the same parabola which is facing upwards, but the minimum point here will be 0, minus 5 instead of 0, 0. And that, my friends, concludes the second form of translation from y to y plus minus a. If you really like this video, please don't forget to like, share, and subscribe.